Okay, so this is chapter 4, which again we cover the linear inequalities in two variables. In this section, this is a very short section. We're just going to learn how to use the graph. So to solve linear inequality problem in two variables. So here to graph a linear inequalities in two variables, and also to solve system of linear inequalities in two variables. We already know how to solve simple equations. That's the whole concept. This is linear. So it's a linear equation. We already know how to solve simple linear equations. And the only thing we're going to learn is the condition inequality, maybe less than or equal, greater than or greater than equal. Based on the condition, we are going to shade some part of the graph. So here they said that to graph the graph of y less than x consists of all the points in which y coordinate, that is y coordinate values, should be less than s coordinate. So to graph this, first of all, I'm going to graph y equal to x. So which means if y is 1, s is 1, if y is 2, s is 2. So I'll get my straight line. By here, the answer should be in the form that always the y value should be less than x. So we need to shade only the part that this condition will be meeting. So here they say the graph of the region y less than s can be found by graphing the line y equal to x first as a dashed line, because the given inequality does not include y minus x. Now the line separates the xy plane into two half planes, because you're going to have where y is less than x, also where y is greater than x. Now, if we know that, we can determine which half plane is the solution. So for example, we may take any point within the two areas and see if it will meet the condition given here, y is less than x. So that's called a test point. So we can determine which half plane is the solution region by selecting as a test point any point not on the line. So here, let's choose 2.0. So this is the solution here. So first of all, you can see that this straight line, the dashed line, it goes through the 0 and 0. Why? Because if we say y, we graph a line y equal to x, it means if x is 1, y also is 1. If s is 0, y is 0. So if s is 10, y is 10. So this is our equality line first. But remember now, the condition, the graph we are graphing is y is less than x. So we can take any point in the half section. I can take any point at the top or down. So let's say, for example, when we took a point 0 and 4, y is 4, x is 0. Is 4 less than 0? No, the condition didn't meet. So we can see this 0 or 4, it didn't work. So we take any point at the top. Now we come down to take any point at the down. We decided to take 2 and 0. Okay. So which means y is 0, s is 2. Is 2 less than 0? Yes. Okay, so we shaded, the blue shaded area will be our answer. So the question said graph where y is less than x. So that would be the shaded area. So next, let's see another example here. Graph the inequality 4x minus 2y less than or equal to 6. So the first thing we have to do again is to graph 4x minus 2y equal to 6. So for example, we can solve for y, then we'll pick any x point and just graph it. And so when we solve 4x minus 2y equal to 6, is the same as y equal to 2x minus 3 when we solve for y. Let's say here y minus 2y will give me 6 minus 4x. So y will give me 6 minus 4x divided by minus 2. And that will give me 2x minus 3. So now we can plot the graph now. If x is 1, let's say we start from 0. If x is 0, y is negative 3. If s is 1, y will be negative 1. If s is 2, y will be positive 1. If s is 3, you pick as many points. Or the best way as we solve graphing a linear equation, we say let's solve for the 2 points, the y-intercept and x-intercept. So when s is 0, y is negative 3. And when y is 0, we look for x value. And that's what they did here. So we get our straight line here. This is when again s is 0, y is -3, and when y is 0, s is somewhere around 1.5 or so. Again, we can solve it from here. When s is 0, y is -3. When y is 0, we bring minus 2s here, so it will be 1.5. So that is 3 by 2. So that's the s and y. Then we draw the line. Then the next thing we can do is go back to the question. This is the question, but first of all, let's solve for y. So with 4x minus 2y is less than 6. If we solve for y inequality, we get this. So we get y greater than or equal to 2s minus 3. So now we want to take any points, our test point. Take any point at the top or the down, above. Now, why this is it's not a broken point. I mean, this is not a broken line. It's a thick straight line, because if you look at the condition, it's including equal. Y is greater than or equal. If it's y is greater, then we make it a broken, which means it's not included. Equal is not included. But in this case, equal also is included. So we have y greater than or equal to s minus 3. So the line is a solid line. If it's a broken line, it can either y is greater than 2s minus 3 or y is lesser 2s minus 3. Then it means equal is not included. But here, equal is included. The reason why we make sure equal is included is that we are going to take any points in either the top of the line or down to see if we meet this condition. But here, since it's greater, the answer automatically will be at the top, because we want always, we get any s value, y should be greater always. So yeah, they decided to use 0, 0. I think that's the quicker way to solve it. So we put 0, 0, and we found out that, okay, 0 is greater than or equal to -3. So the condition is true. So we shade the blue top area. So 0, 0 is here. If you like, you can take -1 and +1, or -1 and 3. You can take any points you want. We're almost done. Somebody is coming to class. So that's how the whole concept is. Next, we have what we call the system of linear inequality. The same thing as we just did right now. This will take maybe a few more minutes, then that's it. So let's go straight to we know system of linear equation means we have 2 equations or 3 equations with 3 or 2 variables. So graphing solution of the system. Here we have, again, 2 equations, 2 variables. So the first thing, again, is the same as we did before. We are going to graph 3s minus 2y equal to 4. Then we're also going to graph s plus y equal to 3, because minus 3 go to equal. So we graph those two. One have a broken line because this is only greater. This is greater than or equal. So we decided to take any point. Actually, we just do the y-intercept and x-intercept. So we find those 2 points. This is a linear. Then we plot it. You see, one is solid line because the condition said greater than or equal, which is right here. 3s minus 2y is greater than or equal. Let's go back to the question. 3s minus 2y greater than or equal 4. So it will be a solid line, including the equal. The 2 equations can be equal. But the next one is only greater, so it's a broken line. Okay, so after we plot finish, now we need to test. Remember, we have intersection here. When you have 2 equations, the intersection of the 2 lines is the solution of the system of linear equation. But here we are not solving linear equation, we are plotting the inequality. So what we say here is that we use any point not on either line as a test point. So they decided to, and what they say not on the line means any point on this line. On this line, let's say if you have 2 and 1, it should be on. So use any point that is not on the line. The quicker way, they use 0, 0 again because it's easier to plug in. So when we use 0, 0, yeah, they say we should know that the coordinate of 0, 0 do not satisfy either this or this. Let's see the reason why. X is 0, Y is 0. Is 0 greater than or equal to 4? No. Minus 3 greater than 0? No. So that means 0, 0 is not good. So by this gives us the idea that our solution is not here because you see 0, 0 fall around to my left where my cursor is. Okay. We know the solution is not here. Since one point didn't satisfy this, that means all the points will not satisfy it. So our solution will be either at the top here, or maybe the right here, or anywhere these two. So now we're going to take any point here or any point here. Again, do not take point on the line. Do not. So let's see what point they use. Well, that's what they are explaining to us. Since 0 didn't satisfy, there's no solution here. So our point will be where the arrows are. 1, 2, 3 area. So let's say they decided to take 2, 1. And if the point you take have to work for both equation. So let's say when we take 2, 1, we have to plug it if it meets the condition. What I mean is that this is the condition you are. The actual question is here. So if I say 2, 1, I will get 6, 2, then we check, then that's 2 and 1. So 2 here, 1 here, which is true because 2 times 3 is what? 6. 6 minus 2 is what? 4. Is 4 greater than or equal to 4? Yes, it meets the condition. Let's put 2, 1 here again. S is 2, Y is 1. 2 plus 1 will give us 3. 3 minus 3 is 0. Is 0 greater? No, that condition didn't meet. Let's see. Let's see the solution again. I don't think they used 2 and 1. Maybe I was. Oh. Okay, so this is the problem. 2 and 1 didn't work. That means we're going to take another point. 0 and 4, let's see. No, this is the old example I gave before. Okay, this is it. So we plot the graph. We tried 0, 0, 0, 0 didn't work. And they explained to us here, because 0, 0 is way here, it didn't meet the two conditions. So here they say the points that satisfy both of these inequality lie in the intersection of two individual solution regions shown in the figure below. It should be around here. So 2 and 1 should work. Maybe I'm making something. Or we may take any point here. Let's say if 4, or if we have 3 here, 3 and whatever value intersect here, like 2.5. But again, 2, 1 should work. Let's see why I'm not getting it. So, okay, 0.21, if you got this, where the two regions form corner can be solved by this. And it's another question. But again, if you plug 2 and 1, it should work here. Actually, let me see. We have 2 and 1. 2 plus 1 is 3. It should be 3 is greater than or equal to 3. And here also should be greater than or equal to 4. Yeah. But the whole concept is that the points should, since we have two graphs, any point we take, the condition, both conditions have to work. So if 2 and 1, 2 plus 1 is 3, 3 minus 3 is 0. Is 0 greater than 0? No. So the problem is supposed to be saying greater than or equal. Greater than or equal, then both will work. So I'll take a note on that. It should be greater than or equal. And I think we're almost time now, so we're going to end it somewhere. Actually, hopefully we shall go through this all over again next week, Monday. Again, this Wednesday, there will be no lectures. It's only the test. So I'm going to wait for a few minutes if we have any question. There's one more example here, but I don't want us to go through. It's almost time now. So again, we will go through all the slides again. We will do more examples on Monday, hopefully. Okay, so if no question, I'm going to stop the recording. Then